Hello everyone. I'm Dr. Red, your science evangelist. I want to make people feel the joy of science, especially those who are not good at science.
And I'm Mike, his friend, whose hobbies include playing guitar and skateboarding.
Today's topic is familiar science, a subject that's often covered, and I hope you'll take a look, because while many of you may know it, many of you don't have a solid understanding of it. So let's get going today. You can accomplish anything.
Hey.
What's with the sudden noise?
I heard that Mars has blue sunsets. It was on TV just now. Do you know?
I know. Me scattering.
You know that. You're such a boring guy.
Why is it that knowledge is boring? It's more interesting when you know something. By the way, do you know why the Earth's sunsets are red in the first place?
Well, is it because it's more dramatic?
Oh, that's a very good reply. It's true that the evening is said to be the magic hour, when the scenery becomes very beautiful. Well, how about scientifically speaking?
That kind of scattering?
That's right. But unlike before, this one is called Rayleigh scattering. I'll explain to you the difference between scattering and the sunset caused by it.
Today I'll listen to you, because I sowed the seed.
Now, I was talking about Mars and Earth, but actually the first thing I want you to think about is the moon.
Oh, we're suddenly in space again. But this time we're wearing a space suit.
Because I couldn't breathe last time. So, what color do you think the moon is at sunset?
I've never really thought about it. But considering the images of the moon landing, it doesn't look like it has a sunset.
Oh, you're right. You have good sense. Why are there sunsets on Mars and Earth, but not on the moon?
It's kind of black. Is it always night?
Boo. The moon also has day and night. For some reason, the sky is black even when the sun is visible. I don't want to be too mean, so I'll give you the correct answer.
Before you give me the correct answer, put the space gun away. You don't have to be so mad at me, okay?
That's true too. It's because there is no atmosphere. The moon has a small mass and low gravity, so it couldn't keep an atmosphere around it.
I see. But why is there no sunset if there is no atmosphere?
Alright, then, let's go back to Earth once. To begin with, the red and blue skies on Earth are caused by the glowing atmosphere. Of course, the light comes from the sun.
Oh, I see.
The light from the sun changes its direction over and over again until it finally reaches Mike's eyes. If the sun's light could reach our eyes without bending at all, how could anything but the sun look bright?
I guess you could say that.
Rayleigh scattering is the reason why the light from the sun changes its direction many times. It is caused by molecules such as oxygen and nitrogen in the air. When light hits something big, it causes diffraction. Oxygen and nitrogen molecules are very small, right? So this is not diffraction, but rather a phenomenon where energy is absorbed by the molecule, and then the same energy is radiated out.
How small is a molecule?
Nitrogen and oxygen are both about 0.35 nanometers. The wavelength of visible light is 400 nanometers for blue light and 700 nanometers for red light. So they are much smaller than wavelengths.
Just looking at the numbers, it's 1,000 or 2,000 times different. By the way, what's the wavelength of light?
I'm sorry. We'll talk about wavelength next time, so can you pretend to know what it is today? Anyway, light is like a ski slalom, moving left and right as it goes. This movement is similar to waves. And the wavelength is the amount of light that advances during one set of movements, going right and left.
There you go. It's a grown-up thing, depending on the order in which the videos are uploaded. Okay.
This Rayleigh scattering by particles smaller than the wavelength is inversely proportional to the fourth power of the wavelength. So, depending on the difference in wavelength between blue and red, blue scatters 10 times more strongly than red.
Oh, this is getting a little difficult, isn't it?
No, not really. But I'd like to explain it in writing, so I'll change places. Look at this picture. The light that comes out of the sun contains both blue and red light. The blue light spreads very fast when it enters the atmosphere. Red light, on the other hand, is less scattered, so it doesn't spread as much but travels farther. But it doesn't mean that it won't spread at all. The sun's rays come in both red and blue together, so let's try layering them. And if we put a human near the entrance to the atmosphere, what would the surroundings look like to his eyes?
It should look blue.
And if you put it farther away, what does it look like?
Red.
Good answer. In other words, red and blue sunlight are diffused in this way. Now, let's apply this to daytime and evening situations. Let's start with daytime. Since the sun is above us, the diffusion diagram we saw earlier will be arranged like this. Then, it looks blue, right?
Indeed.
Secondly, in the evening, sunlight comes in from the side, so the diffusion diagram is arranged like this. Then, it looks red, right?
Oh, I see. You're doing better than your last video.
Thank you. I'm trying really hard to make science fun for everyone.
Keep up the good work. Well, so, for example, if the atmosphere were thinner, would the evening be blue too?
You've got a good point. That's what should happen. That's why the Earth is so beautiful. God designed the thickness of the atmosphere so that it would be blue in the daytime and red in the evening.
Wow, that's so romantic. From now on, I can feel God in every moment. And I have to appreciate the beauty of the sky. Sometimes I stop and look up at the sky.
In a trivia way, you could say that our eyes and brains have evolved to be able to recognize day and night, but God also gave us the mind to be able to see the beauty in it. Anyway, have you learned about the difference in color between day and night? Now, let's think about the atmosphere of Mars.
So Mars has an atmosphere, right?
Yes, it does. It's covered with a thin atmosphere consisting mainly of carbon dioxide.
Wow, I can't breathe in.
The Martian atmosphere is unbreathable in many ways. It's so dusty.
I absolutely hate that planet.
Ha ha ha. On Mars, there's a tremendous tornado called the dust devil that occurs frequently. To give you an idea of how huge they are, dust devils can be thousands of meters high. In some cases, the tornadoes are as big as Mount Everest.
Oh, no. That's too much for any amount of time.
Such a strong wind is blowing up the dust on Mars, so the atmosphere is full of dust. In addition to that, there is a large temperature difference between the upper and lower atmosphere, which causes more dust. That dust scatters the sun's rays. This is called me-scattering.
What's the difference from Rayleigh scattering?
Rayleigh scattering is the scattering caused by particles much smaller than the wavelength of the light, while me-scattering is the scattering caused by particles as large as the wavelength. Dust is much larger than molecules. On Mars, red light, which has a wavelength close to the size of the dust particles, scatters better, so the colors are reversed from the diffusion diagram on Earth. That's why Mars looks predominantly red in the daytime and blue in the evening, as you can see here.
I see. I now understand a lot about the color of the Martian and Earth skies. The sky can't be bright enough without an atmosphere, and the size of the particles in the atmosphere and the thickness of the atmosphere affect the colors we see. At first I thought it was amazing that the Martian sunset was so blue, but now I understand that the Earth's sunset is not a matter of course.
That's right. We usually take it for granted when we see it. But I'd be happy if the viewers could understand that the Earth is a miracle planet.
I'm sure you can.
In this channel, we will continue to post videos on topics that make science accessible and fun.
If you find today's video interesting or informative, please click the good button and subscribe.
Also, please feel free to comment or question. See you in about 30 years. Bye.